Now for deploying that, okay, I'll need to create the HTML or CSS code as well, right? Few lines of code, just the basic, not the extreme one, just the basic one. Okay, so it will take more time. So right now, okay, I'll be showing you how you can create your ML model. Okay, after understanding how you are creating your ML model by using multiple ML algorithms, like the starting with the regression analysis, then we have the few classification projects as well. Then at that time we'll be using classification algorithms. So around around 15 to 20 or 25 algorithms are there in the machine learning. So you can use those algorithm first. Okay, you can get your hand dirty so over there, hands on with that, and then we can go ahead with the Flask. Okay, so it will be easy to understand each and every topic, right? So let us go ahead and just deploy or the read the data set in the Jupyter notebook. Now how to read the data set, guys, in the Jupyter notebook? Now before that, what are the different libraries I need to import? So these three libraries are very much important. Okay, so first let's go and import these three libraries by using the import command. Import pandas as PD. Instead of using pandas, I'll be using PDs now. Then I'll be importing numpy as NP. Then what about third? Import matplotlib dot pyplot. Pyplot is a module in the matplotlib, and with the help of that you can create the multiple plots, okay, in a with the one line of code, right? So let's go and execute this cell by using, either you can simply go and run this, or you can use the shift plus enter, or you can use the control plus enter. There are multiple ways to run this. Okay, and if you are using a desktop, so I guess F5 will be there. If you just press the F5, I guess not for this, but for the in the spider, if you are trying to if you are using spider, or I guess for PyCharm as well, then you can use the F5 as well. Okay, but there is a condition: if you are using the desktop, then only. Like when I was using the desktop, so at that time I used to just F1. By just pressing the F1, which means that the code will be executed. So now after this, let's go and import the data set, and this is my data set WC80. So let's read that data by using, let's say, DF, or you can use any name. You can simply use the WC80 as well, okay, to understand this data. Okay, so first thing, as we know, we are going to read the data. PD dot read, sorry, read underscore CSV is there, and in the in the bracket you will have to add the path. Okay, but okay, let me tell you one shortcut in the Jupyter notebook. Okay, like if you have the data in the same folder that your notebook is, see, this is my notebook. Okay, this is my day 3 regression analysis .ipynb notebook is there, right? So in the same folder I have my data set. Okay, so you don't have to write the the path of the folder, okay, path of your data set, like this. You don't have to write this. Just use your name and the format, like the, let me show you. Okay, wc -at .csv, just use this much. Okay, just this much, nothing else. Okay, and enter it, and here you can see the your data set WC80. Okay, if your data is in the same folder that your this particular your notebook file is, okay, then you can use this thing, right? Now this is my data. Now guys, you can see that the how many rows are there in the data set? 109. How many columns are there? Two columns are there, right? Two columns are there. Now, okay, let me add the aim of my this particular project. Okay, this is a short project, mini project I can say. Okay, so for that, let me add the aim for this. Aim for this. So the aim of this, okay, is to study how well waste. So guys, let us go ahead and go with our code. Like as we know, we don't want to see this much data, because you will see that in the in between you will see that the three dots, which means that okay, it is not showing me the whole data. So what can I do? Okay, I can simply use the WCAT, okay, dot head, okay, to see the sample data. I just wanted to see the top 5 rows of my data. Okay, if you don't want to see the top 5 rows, no issue. You can, if you wanted to see the last 5 rows, okay, you can use the tail method and control plus enter, and here you can see the last 5 rows. See, now again, if you don't want to see the last 5 rows, you can go and use the sample. If you wanted to see the random data and how many random rows you want to see, let's say 7 rows I just want to see, which are totally random. So you will get the random data you can able to see over here. Okay, this is the thing you can do in Python. Okay, which means that for doing one thing, okay, there are multiple options we have, right? There are multiple options we have. Okay, so you can use those options if you know the multiple option for doing the same thing. So it will be very easy to create your own code. Let's say I just wanted to check the shape of the data. Okay, this is for our understanding, guys. Okay, this is for our understanding. Here in the first, you will find that just by using the data, okay, we got the data. But what if our data in millions? Okay, so at that time, if you run this data, which means that okay, you will have to scroll for some minutes. Okay, otherwise you will have to just do this thing. Okay, so you will see like this. Okay, see this thing. Okay, if you click to this, okay, if your data is quite big, so you can do this thing as well, but again you will have to scroll down na? Okay, so if you wanna don't do this, you can simply do one thing. You can go over here, you can use the shape. Okay, so you can simply use the shape, and actually shape is not the tuple. Okay, this is the shape is the attribute, not the function. That's why I got the error, because I added the two brackets over there. Okay, so here you can see that the how many rows are there? 109 rows are there. How many columns are there? Only 2 columns are there, right? Now second thing is that we have to check, is there any missing value present in our data? Yes, we will have to do this, right? So let's go and check. So how you can check, is there any missing value in your data or not? So for that, I told you the here you can see that the backslash, okay, like I just put it the forward slash. So here you see the backslash. Okay, and as we know in Python, backslash is reserved for the escape character. So for that you will have to one more backslash, otherwise it will throw the error, right? So I'll have to put the backslash. Okay, and let me run this, and here you can see again, okay, I got the same output. Okay, right? Yes. Okay, you can go ahead with this. Okay, is dot, okay, is na dot sum, is na to check the missing value dot sum. Okay, so here you can see that in this particular column there is no missing value, zero missing value is there. In the same way, okay, there is no missing value present. Okay, what is another way? Okay, so you can use simply wcat dot info method and run this. Now here you can see that The how many rows are there? 109. Okay, and how many non-null values are there? 109 in both the columns, which means that there is no missing value. You okay, with the help of info method, you can simply compare the how many entries are there. These are the total entries in the your data, which means total rows in the data, and you can simply use this thing, okay, to check. You can simply compare this. If there is, let's say, 108 values are the here, so we can simply say that yes, there is one missing values present in the waste. Okay, also you can use this particular code. Okay, if you are using this particular code, it will give you the the sum of the missing values that is present in your waste. So as we know, there are no missing value right now in the waste column. Yeah, we will be using the few data set in the upcoming session. Okay, those contain the missing values. Okay, initially, why we are going with this small data set? Because it will be very easy to understand the data set and the process as well that we are implementing on the data set. Right now we are implementing the regression analysis on it, right? So it will be very easy to understand. That's why I'm using this much small data set. Okay, as in the upcoming session we'll try to use the larger data set, so you can understand how you can handle the larger data set too. Okay, so this is the again the two different methods. So with that you can check this thing. Now, okay, one more thing, guys. Okay, let's say if you have the 1000 column, okay, or simply let's say if you have the 100 to 100 column. So if you go with this link, okay, either you can go with this, okay, which means that okay, each and every time it will throw you the it will give you the output. But here you can see that for that you will have to check, manually check, yes, is there any missing values or not. Okay, so at that time you can simply put the sum on this. Okay, the sum on this, so which means that you will get the sum of your missing values which are present in your overall columns. Like you put the sum on the each and every column, right? So in the same way you can put the sum on the total all data, so you can simply get the one single values, and on the basis of one single value you can simply check yes. If the value is 0, so you can simply say yes, there is no missing value. And if the if there is some missing value, so you can say that yes, there is missing values present, right? Then you can go ahead and find out which column having a missing value. Is n is there? Okay, is null is also there. Okay, I guess you can use the is null in the R. Okay, or even you can use the is null in the Python as well, but okay, we are preferring to use this is na. Okay, see, there are only two columns now, so it's totally like why to go ahead with that particular thing right now. Okay, if there are a lot of column, let's say in the multiple linear regression, okay, there are, I guess, 7 8 columns. Okay, at that time I'll show you how you can go and do the sum on the overall data. Okay, so it will be practical thing for doing this. Now it's only two, so why to go ahead with that, right? But definitely I'll show you on the bigger columns data set. We imported the matplotlib library as plt, so I'll be using the plt dot, let's say I just wanted to create the histogram first. Okay, by using the one column. Okay, and how to check that column name? Okay, let's say by using this, or we have the, let me add the one more cell over here. Okay, with the help of wcat dot the columns. Okay, just use this particular attribute and you will see that the okay, it will give list of the your column names. Okay, so you can do this thing, and let's go with the first waste. So for that, again wcat dot now waste, and let's run this, and here you go. Okay, here you see. This is just the beans. Okay, this is just the beans, and here you can see the values for those beans. Okay, so if we're talking about the x-axis, so x-axis is nothing but the different classes. As I told you, the bins about the the bins in the yesterday session. Okay, so these are nothing but the bins. Okay, here you can see that the from the starting point, let's say this is the starting point, let's say 60. Okay, this is the first bin, 60 to 17, then 70 to 80, 80 to 90, 90 to 100, like that you will find that each bin. Okay, right? And you will find that the the how many points, how many data in between these bins. Okay, then these values, this range, so that is what we are showing over here, right? Here, okay, the main thing is to don't get into the bins. Okay, the main thing is to get into the different interpretations of the histogram. What is the purpose of creating histograms? Okay, let me show you. Okay, as I told you yesterday, bins are nothing but, let's say we have the 1 to 100 data points, and you can see that I just created the bins, right? Okay, let's say 21 to 30 up to, you will see that the 91 to 100. See, and here you will find that how many values are there in your data which is in this particular range, so let's say we have the 4 values for this, we have the 5 values for this, we have the 9 values, like this. Okay, so you will find that, okay, this thing, right? Okay, so in the same way, here you can see this thing. Okay, here you can see this thing, right? Like in Python, it will it will create, it will select all. Okay, it will do all the things automatically, you don't have to worry about it. Okay, like the bins and all. Okay, just use this particular plot and it will create this histogram for you. Okay, and this histogram is a standard one, right? Like by using the formula for creating the bin, how many, okay, how many bins which are standard or the important for this particular data, like there are only 109 values are there, so how many bins we require for this. Okay, so he can automatically do all the things and he can present you the histogram. Okay, yes, so by default, it will set the bins for you. Okay, you have to worry about the interpretation, how you can do the interpretation. Okay, right? So here, if we talking about the interpretation of histogram, as I told you yesterday, you can find out the range. Okay, range of your data. Like as we know, the standard range of the age column is between 0 to, let's say, 100. Okay, like our age, the human's age, the standard age is between 0 to 100. 0 is newborn, 100, it's, I guess it's a very extreme point. Okay, you know or 80, 80 is sufficient, I guess, 0 to 80, right? So that is the standard age range, right? So this is how you can say this is nothing but the range of the waist circumference, right? This is the range of the waist circumference, let's say from 60 to 120, right? Now what about next? Okay, here you can see that the distribution of this particular data is the bimodal because there are two spikes. Okay, this is the one, this is the second, which means that there are two modes, right? Okay, here you can't say that this is a positively skewed and negatively skewed, because you will find that there are two spikes. Okay, that's why you can't say that it is positively skewed or negatively skewed or a symmetric distribution. Okay, so like this you can identify few insights of your data. Okay, and that will be very important for you to understand your data, right? like how many times, like the how many times that value repeated in the data. So see this value here, in this particular, okay, this particular bin has the highest value which are repeated in our data. Okay, so most frequent values, right? This is nothing but the mode. It there may be, single mode distribution, okay, or a bimodal like this. Okay, this is a bimodal distribution, right? Or you may got the more than three modes as well. You will find that the trimodal distribution, but that will be a very rare case, right? Now then what else you can find out? The range, the mode you can find out. Then you can find out, okay, the skewness. Skewness is nothing but the shape of your distribution, whether your data is a positively skewed or negatively skewed, or you're symmetric. Okay, like as we discussed this yesterday. Okay, so here, we got the bimodal distribution, so we can't say that yes, we can't say that there is a positively skewed or negatively skewed distribution, or even a symmetric distribution, because this is a bimodal distribution, right? Then here, okay, we also find out the kurtosis. Kurtosis is nothing but the shape of the distribution, as one mentioned, tail. Okay, is there the, like, is the distribution which is having a long tails are nothing but these values. Okay, these values here you can see, or these values. Okay, so this is the thing, mean the end point value. Okay, either starting or ending, right? So if these values, if you see, okay, these values are present in long term. Okay, so you can say that there is a, platykatic distribution. So that is nothing but the kurtosis measurement is there. Okay, so like this, okay, you can identify few insights from your data. So again, we are using the, you know same column, right? Waste column. Okay, and we are finding out the box plot. WC80 is nothing but my data set, and I'll be creating the box plot of the waste column. Now here you can see box plot. Okay, so as I told you yesterday, guys, okay, as we know, we can find out the minimum value from the box plot, right? We can find out the maximum value from the box plot, right? So we can find out the minimum and maximum value from it, right? We do not find out the average value, like with the box plot. This is nothing but the Q1. Q1 is nothing but the 25th quartile, right? 25th quartile, or in simple word, you can see Q1 is there. Okay, then yes, median is there, 50%, or the second quartile, which is also known as the median. So these are the few different things we can find out. Okay, even if you go in the deeper, okay, you can find out the, the whether your data distribution, is the, positively skewed or negatively skewed or symmetric, which means that you can even find out the skewness as well. Okay, you can even find out the skewness as well as the kurtosis. This is the 25th percent, right? This is the 50%, this is the 75th percent. Okay, this is the Q1, Q2, and Q3, right? Okay, this is the minimum, the below line. This is the maximum. Okay, these are nothing but the Q1, which is the 25th percent, right? 25th percent observation. This is the 50% observation, and this is the 75th percent observation, right? So I can simply use WC80 dot describe, right, and run it. And now here you go, minimum, Okay, maximum value, 25th percent value, 50% value, and 75th percent value, right? And you can reach a cross check, okay, whether these values are correct or not for the west column. Okay, so this is my box plot, and these are the features. Okay, now, okay, there is one task for you. Okay, now you can do is you can just go ahead, okay, and try to find out the histogram for the 80 column. For which column? 80 column, and try to find out the box plot for the same column. Okay, and after finding out the box plot, okay, then try to understand where is minimum value, where is maximum value, 25th percent, 50% and 75th percent. Okay, so that's what you can do after this particular session as well. Okay, now guys, after this, okay, as we know in the regression analysis, okay, I'll have to first understand the relationship between the the let's say the variables. Okay, so for that, yes, I'll have to create the scatter plot for this. Okay, but you know like we'll create the scatter plot as well. Okay, but we'll create the scatter plot, okay, with the regression line, right? Then you will understand this thing. Okay, so like let me create the scatter plot for your understanding. Okay, scatter, then I can simply use the as we know my x variable is going to be the west. Okay, west circumference, so I'll simply use the wcat dot west. Okay, and my y column is going to be the 80, so I'm gonna use the wcat my data set, and 80 column is there, right? And let's go and run this. Now here you can see for this I'll have to see guys. Okay, when we are dealing with the understanding these things, okay, so you will have to understand this one by one. Okay, you can create this multiple, okay, you can create this thing, okay, this plot, okay, for the multiple in ones, okay, like, but you will again get the small part, okay, and somewhere here you will find the another plot. Okay, I'll show you in the upcoming part, okay, when we are dealing with the large data set. Okay, so you will understand, yes, we can do that again. Okay, but if you are visualizing this particular data, okay, let's say this particular histogram, so that will be very easy to understand. Okay, if there are a lot of data, if there are a lot of plots, okay, so it's very complicated for you to just go ahead with each and every plot, right? So create one plot and understand this plot first as a beginner. Okay, then if you know this thing, okay, and then you can create the multiple plot, 9 plot in a one graph, and you can simply go ahead with your insights, right? Now this is my scatter plot. Let me show you the value of correlation, right? So there are multiple ways to find out the correlation. One way is too simple, just go ahead with the wcat.at, right, and use the core. Core is for the correlation, okay, and in bracket use again wcat, the another column, which is nothing but the waste column. You can either use the column, okay, first 80 and then waste, or you can use the first waste or 80 then. Okay, both are same. Okay, let me go and run this now. Okay, this will be the the value for this. Now let me you will see that the few very decimals value like 0.8185. Okay, so let me round this value to only two decimals. Okay, so for that I can simply use round, and in the end I'll have to add the how many decimals I want. Okay, for that let me zoom this. Yes, and here you can see first I use the round, and in the end you will find that I mention how many digits I want to see. Here you can see. Got it? So that's how you can go ahead with, okay, and find out the correlation. Okay, now what about any alternate method for this? Okay, so there is alternate method. With the help of this, you can simply use this. Okay, the numpy library, as you know. So with the help of numpy library, np dot correlation coefficient. So it is basically very influenced by the statistical professionals. So also created by the statistical professionals. So that is why you will see that in the statistics, okay, we will be talking about the correlation, okay, in terms of correlation coefficient, right? So that's why here we got the short form for this core coef. So use this core coef, and in that just use the two column names. So as we know, first column name is this because first I'll have to add mention that data so I can extract the column from that data. That's why I'm doing this thing. Okay, so this is my first. Let's go ahead and copy this from over here. Okay, or even you can type it and let me run this. Now here what we got, we got the array. You see that the power of np numpy. Okay, we got the array. Okay, you see that if you go and find out the correlation of this with itself, so the correlation for this is 1 with itself, the same parameter if you are using. Okay, and waste, so here you can see the correlation of AT and waste is this much as well as this much. Okay, because okay, whether you use this term first or this term first, okay, like you will get the same output, right? As I told you over here, instead of AT here you can use waste, and instead of waste over here you can use AT, then only you will, okay, then also you will get the same output. Okay, there is no difference in the output. So this is the term. Now guys, after understanding this term, here we got the correlation in between these two columns, which are nothing but 82 or 0.82 or 82%, I would say. So which means that yes, okay, okay, there is some kind of correlation which is more than moderate correlation. Okay, moderate positive correlation is there, but not a very less moderate. It's not a it's somewhat which is very much tends to strong, I would say, right? Strong positive correlation, but not that much strong, because here we got the correlation is only 82, not the 90% or not a 0.9% or 95, right? So that's why here, okay, we got the correlation which is 0.82, which is between moderate or strong, which is between the moderate and strong positive correlation. Because we got the positive value, that's why we are saying positive. And also here we cross check that yes, our data is going in an upward trend, so we can say that yes, there is a positive correlation, right? Okay, now guys, let us go ahead and build the our first simple linear regression model, which is a like for many of you guys, this is your first machine learning model, I would say, right? So let's go and build that model. Okay, so it's very easy guys. Okay, in Python you will have to add few line of code. Okay, and it will create your model, nothing else. You don't have to find out the coefficients of your model, not like that. Okay, just use one line of code and it's all set. Now let's go and use the different libraries for creating the regression model. Like first I'm gonna use the stat models library, because stat models library is created by the statistics professionals, and in the name itself there is a stat models. So regression model is basically is from the stats model. Okay, this is nothing but the stats model library guys. This is very important for the regression analysis, and believe me guys, it will give you a summary which is very much interesting, right? Which is very much interesting. So guys, let us go ahead and why we are using stats model. Okay, we are using stats model for building the regression model guys. This value is nothing but the correlation between AT and waste, right? And the same value, this value is again the correlation between AT and waste. Okay, but you will see that numpy array mostly give you the output in terms of array, in terms of array. Okay, like I'll show you. Okay, here if you have the, let's say if you wanted to find out the correlation of x and y, okay, so by using numpy it will give you the no the correlation of, here you can see that the xx first, then correlation of xy, then correlation of yx, then correlation of YY. So as we know, there is one theorem, you can go and check it out. Okay, the value of correlation of X with itself, which is 1, the value of correlation of this Y with itself is 1. So you will find that over here, value is 1. Okay, the diagonal values are 1 because of this particular thing. Understood? Now the second thing is that this is a correlation which is showing that 0.82 if you round down. Okay, if you round this formula dot API, we have to go with the API. Okay, because okay, after few line of code you will understand okay why I am using stats model for building the regression analysis. Yes, is there any different library? Yes, we can use that library too as well. If okay, if we got the time at the end of the session, I'll show you how you can use any other library as well, let's say sklearn library, to create the regression model as well. Okay, I'll show you that as well. Okay, but first let us go with the stats model. Okay, so this is the stats model dot formula dot API as SMF. We are using SMF instead of stats model dot formula dot API. Understood? So let's create the model. Okay, and I'm gonna use okay the SMF dot OLS. OLS is nothing but the ordinal least square regression model, right? So I'm gonna use the OLS model, so which is one of the regression model. With the help of that you can find out the coefficients of your regression model. Okay, this is not any other thing, this is just the ordinal least square regression model. Okay, as I as we discuss about the regression analysis y equal to beta naught plus beta 1 x, guys. Okay, so we are finding out the from the data we are finding out the value of beta naught and beta 1. Okay, so with the help of OLS we are just finding out the value of beta naught and beta 1. Okay, don't worry, I'll explain this thing. Okay, after few line of code, then you will automatically understand okay this thing. Let me create the model. Okay, let me write the function. As we know, our aim is to you know predict the AT from the which one, waste, right, from the waste column, isn't it? Right, so we just created the formula for this, and we are providing the data. And which data we are providing? The our WCAT data we have. And after that, after building the model, what we can do, we can simply fit this particular ordinal least square model, okay, to fit our regression equation. Okay, so that's it, dot fit, which means that create the model in short. Okay, we are commanding to our system like build the model like this. Okay, which can you know show you the formula like this is the y value, this is the x value, this is my data. Okay, and build my model, that's it. Okay, we are just commanding to my computer or to my laptop saying that build my regression model by using this particular line. Now see, it is taking some time now, right? It is taking some time, you will see that now we got the output.